now. Okay, just says recording in
Yes.
progress. Start. Now. Go ahead.
Hello and welcome everyone. Jyoti here from the group Neural Wizards. First of all, I would like to thank SIF and DigiLABS for the opportunity to participate in the AI Foundational course. Now, I would like to introduce my talented team members, Gary, Sudipto, Aman, and Manasvi. Today, we are exploring a sustainable approach to promote responsible consumption and production using AI. Our focus is on harnessing this technology to identify overripe and ripe fruits and vegetables, aiming to minimize food wastage and foster a more sustainable food system. Let's understand the AI product cycle. Generally, AI product cycle consists of 6 parts: problem scoping, data acquisition, data exploration, modeling, evaluation, and deployment. Now, let's come to the problem scoping. Coming to problem scoping today, we address the pressing issue of overripe fruits and vegetables. This pervasive problem not only leads to significant food waste, but also impacts the economy and environment. Our focus is to understand its root causes, explore innovative detection methods, and devise sustainable solutions to mitigate these effects. Now, I would like to call my teammate Gary to identify the UNSDGs. Over to you, Gary.
Thank you. Identifying the UN SDGs. Our project lends itself towards SDG 12 by applying AI to reduce food wastage in detecting ripe and unripe produce. We believe that this process will likely contribute towards the end game of zero hunger and SDG 2 and better health and well-being in SDG 3. In forming the problem statement, we also look at the major social aspects of irresponsible food consumption and production, namely health issues and social disparities, impact on the waste management systems that will harm the environment, and also acknowledging that 1.3 billion tons of food is wasted every year. Next, we apply the 3W1H to understand the process better. Who, the first one, will benefit from this particular project? We look at orphanages, refugee communities, soup kitchens, food banks, and many others will be added prior to deployment. Next, where? In terms of looking at where the source could be, we decide that the farms and co-ops as well as markets could be a start. When we will start to introduce this, we anticipate showcasing the AI solution at conferences and forums, inviting stakeholders to take a more active role. I next introduce you to Aman, who will continue the next.
So these goals, which Gary has mentioned, can be achieved by redistributing and repurposing overripe and ripe produces, and also applying the drip freeze drying method to minimize food wastage. And coming to the 3 domains of AI now, there are basically 3 domains: statistical data, natural language processing, and computer vision. Due to the nature of our project, computer vision is more appropriate to effectively detect and differentiate between overripe and ripe fruits and vegetables. Now, coming on to types of AI projects, extending on the 3 domains of AI, our project is image-based, so the audio and post projects are not applicable at this stage. Now, let's talk about splitting the training data set for evaluation. Coming to the point of splitting data, we use 3 data sets, namely cell, donate, and test. We created separate folders for cell and donate images to train our machine, and collectively 960 images were used for training. That accounts to overall 80% of our overall data. We then created a test folder which accounted for 240 images and 20% of our data. Now, I would like to hand over the presentation to Sudipta.
Hi. During data acquisition, during our project, we believe that detecting the right produce for sale and identifying overripe produce for donation would effectively minimize the food wastages. Additionally, our team was engaged in a collaborative effort with each member tasked with gathering 125 images of ripe fruit and 125 images of overripe fruit to mitigate duplication. To access the accuracy of our model, we collected additionally 50 images of ripe and overripe fruit for evaluation. Data exploration. For data exploration phase, we searched our images from various platforms such as Google, Bing, Dreamtime, and other websites housing extensive datasets of fruits and vegetables. Employing diverse prompts, we collected the dataset tailored to our research objective. To validate data, we cleaned, structured, and reduced biases to generate desired output. Modeling. During the modeling phase, we utilized a neural network architecture based on uh, pre-trained model VGG16 in Keras. Initially, we trained the model with 80% of the collected data and subsequently evaluated its validity and accuracy with remaining 20%. The, this process involved leveraging the pre-existing knowledge encoded in VGG16 and further fine-tuning it to align with our specific requirement. In total, our model was trained on 1,200 images. Classification of ripe and overripe fruit. Coming to the process of overripe and ripe detection, first we provide the model with the input of ripe and overripe produce. Then we train the model using deep learning, and finally, it produced the desired output by differentiating between ripe and overripe produce. Now I will hand over to Manasbhi.
Thank you, Sudipto. Now we are moving ahead with the evaluation aspect. In this aspect of confusion matrix, 0 means sell and 1 means donate. We obtain true positive value as 103 and true negative value was 108, while the false positive and false negative values were 9 and 21 respectively. From all these terms, we got an average F1 score of 0.88. Now we are heading towards key reflection. Nowadays, AI is playing a major role in our environment and lifestyle, advancing sustainability and cohesion. It can even solve complex tasks if trained properly. As such, it's imperative for developers to be more accountable and transparent in AI ethics and governance. We also need to ensure cybersecurity. Deep learning is widely practiced with strict protocol to improve compliance and security. If we look towards project application, some of the future applications of our project are engaging government, world leaders, and stakeholders to address food wastage and solution to responsible consumption, promoting sustainability to increase collaboration. In the conclusion, I would like to add leveraging deep learning for ripeness detection offers a promising solution to address food wastage and hunger simultaneously. By embracing technology and collaboration, we can create a more sustainable and equitable food system for all. Thank you for your attention. Let's work together towards responsible consumption and production to elevate food wastage, sustainable practices, and ultimately achieving zero hunger. Thank you once again.